Just going to look at resisted motion going down, where the force is mkv squared. And we're going to focus on finding x in terms of v to start with. Okay, so the thing's going down, so that means positive will be down and negative will be going up. So that means x is 0, v is 0, because it's just dropped. I'm just going to drop it from that height. And time is 0 if you dealt with the time. So x double dot, mass times acceleration, is the sum of the forces. So the resisted force would be minus mkv squared, and the weight is mg, which is positive. So it's minus mkv squared plus mg. The m's will cancel, so x double dot is minus kv squared plus g. So basically, what we want to do here now is I want to find x in terms of v. So I'm going to go v dv on dx equals minus kv squared plus g. We go v on g minus kv squared dv equals 1 dx. All right, I'm going to integrate this, and I'm going to do it from velocity 0 just up to v, and from 0 up to x. So this side we have x from 0 to x, so it's just going to end up being x. And this one from 0 to v. Now, the derivative of that is minus 2, so you go minus 2 nk. So minus 2k is what I'd have to divide by. Minus 1 on 2k ln g minus kv squared. Okay, and we're going from 0 up to v. So it's minus 2kv ln g minus kv squared minus 2k ln g minus k times 0 squared equals x. So it's minus 1 on 2k ln g minus kv squared equals 1 on 2k plus 1 on 2k ln g equals x. So that means that x is 1 on 2k ln g over g minus kv squared. Okay, all right, so that's x in terms of v. If I wanted to make v the subject, so then I go 2kx equals ln g on g minus kv squared, and I just have to rearrange this. So that's e to the kx equals g on g minus kv squared. I'm just going to flip it so I get the g minus kv squared on top. So when I flip this, it actually becomes just a negative indice. So it's e to the minus 2kx equals g on g minus kv squared. Rearranging this here. Okay, we're going to get the... sorry, I flipped it. Why did I? I already flipped this part. I'm flipping it again. Okay, so you get g minus kv squared times g, because I'm going to move that g to the other side. And then I'm going to move this over here to make it positive. So kv squared is g. And then I'm just going to bring this one back here and subtract it. G e to the minus k x, minus 2kx. Divide by k, and you get g over k minus g over k e to the minus 2kx. And you got v equals the square root of g on k 1 minus e to the minus kx. Now, that's velocity in terms of x. So if x went on forever and ever, you would actually also approach your terminal velocity, because it would be root g on k, and the 1 minus, now the 1 over e to the 2kx will get bigger on the bottom, so that'll go to 0, so you're going to approach root g on k. Another note on the terminal velocity, our original formula, x double dot, was g minus kv squared, and when the acceleration equals 0, you're going to get exactly the same thing for the terminal velocity. You're going to get g on k equals v squared, so v is the square root of g over k. Oops. go to here and just highlight that. So that's the terminal velocity coming out again. This is v in terms of x. And if you come back up here, we also found, where is it? Here, x in terms of v. And once you've got these formulas, then it's very easy then, like if you want to get anything, like if you want to put in something for the velocity, you can find the height at that time. And just remember the height is always taken from that top position. You could continue with this and just get the time in terms of v for the same motion. So that's acceleration equals g minus kv squared. If I want to get anything to do with the time, I go dv on dt equals g minus kv squared. 1 over g minus kv squared dv equals 1 dt. Now this gets a little bit harder because integrating this, you've got to think about something that's a bit more, like basic, like you might go like that. So when you split that up, you get a plus bx. And when you find the common denominator there, you'll notice that it's almost the same thing. Plus a minus bx, like they cancel, over a minus bx, a plus bx. You get 2a on top. So it's really just 1 on 2a. If you put that out the front, you'll have the same thing. So if you set it up like the one I've got above, then you know that it will actually give you the same thing. So your a is actually root g, and your b will be root k. So when you do go to split that up, that'll be 1 over root g minus root kv plus 1 over root g plus root kv dv equals, now on the other side, I'm just going to do this from 0 to t. That's going to be t from 0 to t. And this one here I'm going to do from 0 to v. So that means that you're going to get, the derivative of that is minus root k minus 1 on root k ln root g minus root kv plus 1 on root k ln root g plus root kv equals t, because that'll be t minus 0. And we are doing this from 0 to v. So it's going to be minus 1 on root k ln root g minus root kv. Actually, I might just simplify the log a bit first before I sub it in. So it's 1 on root k ln root g plus root kv on root g minus root kv. And we're going to go from 0 to v. So it's 1 on root k ln root g plus root kv over root g minus root kv minus 1 on root k ln root g plus 0 on root g plus 0, which is ln of 1, and ln of 1 is 0. So that means that your t is 1 on root k ln root g plus root kv over root g minus root kv. And that is the time in terms of the velocity. If you wanted to, you could then rearrange it to actually find the velocity, which is a bit of a task, but it's not too bad. Like you've got root kt equals ln root g plus root kv on root g plus root kv. Sorry, that should be minus. So e to the root kt equals root g plus root kv on root g minus root kv. And I think then we could we bring this here, root g e to the root kt minus root kv e to the root kt equals root g plus root kv. Get the v's to one side, the g's to one side, so it's root g e to the root kt minus 1 equals in v. So when you take the v out, it'll be root k e. Sorry, we'll go root k v 1 plus e to the root k t. Okay, so then getting v by itself, v would be root g on root k, e to the root k t minus 1 on e to the root k t plus 1. So v is root g on k, and if I divide the top and bottom by root kt, get 1 over minus root kt over 1 plus e to the root kt.